All right. So let us do this one more question. Question number 40. And yeah, two big problems. One, question number 40. Hmm. Right. So you have this A is a m by n matrix, okay, and there exists some B1. Okay. There exists B1, which is a m cross 1 matrix such that AX equal to B1 has infinitely many. Again, this infinitely I'm just writing just to say that it's not finite. Okay? Has infinitely many solutions. Hmm. Let B2 denote. I'm just writing it was what would we say? Transcribing. Or maybe just writing it verbatim, right? Let B2 denote some, or just, yeah, and it would denote as, okay, and an m by n matrix different from B1. Okay? Then, what can you say about this? This has, maybe write the options also. I just ate something, maybe a little slow now. Actually, yeah, Zoom is taking a lot more time to what we call it. You know? It's waiting period for non-subscribe, or unpaid version is sort of increasing. Infinitely many solutions for some B2. This is option 1, and the second is a unique solution. A unique solution for, yeah. So you people know better. You have tried the question. No, so which one is correct or which one is not correct? Definitely, you can eliminate some. No solution. And D is finitely many solutions. Sorry. Yeah. So any comments on any of the options? You can just see this from the angle of system of equations. Okay. Then you can.
Yes, sir. That's what I actually did. I just
Uh,
enumerated all elements of A, and then X, and then B1, and then I was seeing what to do with that. I put it, I got the equations.
okay. All right. So what do you get? Think. it's really about whatever observations you can make on your own, that will count, because that will really be your
Sir, I think A is right because uh, one second, sir. I'll
is this multiple correct? Then our previous question would can be wrong. Multiple select question. Okay, then you can just look at the previous problem. If there is something else which can always zero, you can just see, because you only got one of you only anyway. You can just look at it. It's not so. In this, multiple can be correct, because it looks to me that multiple are correct. So I went and looked. So yeah, pick your favorite one and try to see if it is correct. Yeah, and then take your turns and tell me, say something. Or you can just take small cases, right? Take a one equation and two variables and see what you can say. Right? Take the simplest, take a line and see what you can say. Take a line in plane and see what you can say.
Sir, A is right because in B2, if we have, we can make it different from B1, but we can also do something like one element is like a scalar multiple of the other. Then I think we would have infinite solutions
So can
because
you
we would
say
have fewer equations than variables.
fewer equations and variables? I don't quite. It's not correct. Right? But as you said, right? Just do something simple. Just take b2 equal to 2 times u, right? Yeah, no, yeah, there will be infinity many solutions.
Yes, sir.
Yeah, but
Yeah.
this is obviously a means obviously, but this is what I'm saying is the bad way. You should know better. So I have said this right in the past, that these are cosets, these are translates, right? So if you just focus on this one, A is correct. But if you look at this one, then I have said, yeah,
So, but so what if B1 has only zeros as its elements?
right, yeah, then we should see, yeah. So when you look at this case, mm, then also it is right, correct. That's a good observation. In that case, yeah, one is not correct necessarily, right? Because yeah, that's a good catch. I mean, yeah, it's a degenerate situation, but it is there, right? Because A can be zero and B1 can be zero. In that case, this has infinitely many solutions and other things don't have any solution. did not
Yes.
say
Yes,
non-zero.
sir.
Yeah, so they said distinct
The A
solutions or
is
some,
wrong actually.
right. So in that case, yeah, I mean, in spirit it is not wrong, but I mean, yeah, it is wrong in this extreme situation. I would probably put A not equal to Z, not zero metric. Or if they said that there are, and because see, they have said M is bigger than 1, right? So they are trying to tell you something, but probably they have not told the correct way. When they say M equal to 1, maybe they want to say there are more than one equations, and which would mean some equation is non-zero, which would mean A is not equal to 0. But it's not written like that. So yeah, what is written, A is wrong.
Sir, and then B is also wrong. The same reason.
A unique solution for some B2. Yeah, then it is wrong because yeah, no solution for some B2 is correct because there is no solution for anything other than 0. And finitely many solutions, yeah, 0 is finite, 0 is finite number, then it is correct. So it's like the if the entire thing becomes opposite. Yeah,
So
this is
I think they wanted us to put like the zero, like the matrix with zeros, and then consider maybe like that was the goal of the question.
I don't okay. I will not agree to that because that is not math. That is not then there is no mathematics involved, right? Then you're not testing your linear algebra. They are just test. I mean, from that angle, but I don't. It is uh, yeah. But if we now so the problem is solved. If there are any questions, then tell me because then no linear algebra is tested. It is just yeah. But anyway, we don't want to get into all that. If a is not equal to 0, then what will you say? Now let us try the question. Well, now maybe some small linear algebra can be used. No? Yeah. So if a is not equal to 0, then this is correct, right? We just said. But then what is the good way to see? So I have said this, right? That if you are looking at any B1, then what are the solutions of AX equal to B1? What are the solutions of AX equal to B1? So just think about it. So AX equal to B. Yes. Okay. If you collect the x's, right, x such that AX equal to B. Okay. Let us imagine that, let's assume that n is equal to 1 in some easily. Then you will have something like this, right? A1 x1 plus A2 x2. Let's take three variables, right? Equal to some number B. Then you're just looking for these things, x is x1 comma x2. Okay. So you're looking at these x's. So what are these? What is this geometrically? See, geometrically, this thing will be a plane, right? Geometrically, this thing will be a plane which so right. So to explain it, I mean, I've earlier said it in a different way, but now I'm just trying to say it geometrically. Yeah. So look at this thing. Yeah. Look at this thing. What is this thing? For understanding this, you look at this x, y, z, and then you consider this vector, which is so this is basic 3D geometry. Okay. This is A1, A2, A3. Maybe I'll just call it A, right? So you understand. A, and this is a vector. This is a vector. And what this is saying is that this is saying that I want those vectors x such that A and x are orthonormal, right? This is the dot product. This is the dot product of A and x is equal to 0, correct? So you are just asking for a plane which passes through the origin, of course. You can see 0, 0, 0, 0, 0 is solution. It passes through the origin and it's perpendicular. So this is the how do you do it? This is in the plane. And so this is the orthogonal. So now tell me what will these points be? What will this upper set, this set S, how will that look like in 3D space? The lower thing we saw that it's a plane which is perpendicular, blah blah. How will the upper one look like? No. So the upper one will be you have to. I mean, provided it is non-empty. If it is non-empty, then there is a point in it, right? So let's say uh, just take something, right? Just P0, P1, P2, P1, P2, P3, right? So then you just take that and then you get, okay, so I am taking P1, P2, P3 as a solution. Okay, then you see this thing becomes equal to 0 because P1, P2, P3 is a solution. So by definition, this thing is equal to 0. Correct? So what has happened, right? So this set S is the same as this set, right? Is the same as this set. I have not changed anything. The P1, P2, P3 is one fixed solution. Then X's will satisfy this is same as X's will satisfy this, right? And then what is this? This is basically the origin moved to the point P1, P2, P3, and then a plane. So this is basically will be a plane passing through P1, P2, P3, right? Which is perpendicular to again that same vector A1, A2, A3, right? So basically, I'm just saying that you have to shift this plane that you have parallelly, right? By just yeah, just shift this plane parallelly so that it passes through P1, P2, P3. Right? That's all. So P1, P2, P3 is here, and then you just shift this plane parallelly, but however you want to draw it. It's parallel, right? This is our S. So basically, our S is an affine plane, which is the shift, which is basically the original plane, which is shifted, okay, it is shifted, and you could say it's shifted along the vector a1, a2, along A, yeah, so that it will remain parallel. But you can just say shift it parallelly so that it starts passing through P1, P2, P3, right? What is the distance that it gets shifted by? Not needed for this problem, but uh, but yeah, please tell me what will be the distance. So I'm just asking what is the perpendicular distance of this thing from the origin? I mean, yeah. So yeah, if you drop a perpendicular from the origin to this plane, then what is that length? Yeah, you can easily compute it, right? So it will be B by mod A. Please check it. That will be the distance. And all this you can do. So look at this situation, okay. But what we understand from here is, what do we understand? We understand that any solution of this, any solution of this is coming from a solution of this is same as solution of this, right? And any solution of this is basically a solution of this, right? Solution of this shifted by P1, P2, P3. You can see it geometrically, you can see that, right or wrong. If you want, you can write Y here, right? So you can check if X satisfies this, okay. If X satisfies this and you subtract P1, P2, P3, then you get that, you get something that satisfies this. And if something satisfies this, you add P1, P2, P3, you get something that satisfies this. So there is a correspondence. I have said this earlier, these things are right. And so what do you get? You get that for Ax equal to 0, you have infinitely many, because the number of solutions is in bijection. Okay, I have said this earlier. So is this correct? Is this clear? Or, so the solutions are coming in this nice way. Solutions are coming in this nice, provided, but I used crucially that there is a solution. If there is no solution, then there is no solution. That's also possible. So obviously, you cannot have unique solution, because I just said, I mean, just know that there is either no solution or there are infinitely many. So this is not. And then no solution for some B2. Who wants to think about this? And then finitely many solutions is not possible. We just said either because we the way we said this, we know that we cannot find it. I mean, okay. So again, degeneracy is there. I mean, it depends. If you can answer first, let's answer C. Then so can you say that there is no solution for some B2? So there is some B2 for which there is no solution. That is an interesting question, because it's not maybe obvious. So let's, yeah, okay, you think. I would say this is yes. So there is a B2 for which you cannot find any solutions. But we are using the fact that there is some B1 for which there are infinitely many solutions. Even I might be wrong actually. Yeah, it might be that there is a solution for every B2. Yeah. So what do you think? I mean, look, if you take the last picture, right, then also you can answer the question. If you look at this picture, so what is it? The solutions for ax equal to 0, let's say that is 0, right? X equal to 0, you know that there are infinitely many solutions. As you get, you have concluded, right? That ax equal to 0 has infinitely many solutions. Now, as you shift the plane parallelly, right? As you shift the plane parallelly, what happens? Yeah, what happens? So, what are we doing? Let us look at it slightly differently. So, how do you draw a nice picture? Like this? Yeah. So, this is passing through the origin. Okay. And obviously, this is it's not a finite plane, it's an infinite plane, of course, right? It's not bounded or anything, of course. So, yeah, goes on and on. Yeah. So, this plane. Now, you see, now you are given some B2. Okay. You are given some B2. Okay. Some B2. You want to know if there is a solution. So this plane means that this plane is set of all points x such that ax equal to 0. This is this plane that I have drawn. Correct? Okay. Now you want to know if ax equal to b2 has a solution. Right? So how would you get to x equal to b2? I mean, if I shift this plane parallelly, I think I can reach any b2. No? Yes or no? Right? I have this plane which is passing through you. If I shift parallelly, then I can reach B2 at one point, right? So I do a parallel shift and I can reach this B2 at one point. Okay. And if I'm shifting it parallelly and reaching B2, it means that I get a plane, yeah, which has the same perpendicular, which means it has the same A, it has the same normal because I've shifted it parallelly. And so I will continue to have infinitely many solutions. I will have solution for that B2. Is this correct? Is this making sense? Obviously, in this case, A is a single
It
equation.
seems, yes, sir. It makes sense.
Makes sense, right? So,
Yes, sir.
yeah, so this is the situation. So, in the case of a single equation, it is correct. Okay, so in the case of a single equation, meaning that m equal to 1, and so our situation is m equal to 1, n equal to 3, it is certainly correct. And when you do linear transformations, then also we can prove this using rank nullity. You would, would need that, I think. Yeah, it's correct. But then in general, this is not correct. Can you think of a situation where it is not correct? So that is the problem actually. In general, this is not correct. And how would you get this? You get this by the row reduce echelon form sort of business, right? Or just imagine, right? So you row reduce and you get something, just check. Uh, how do you do? So yeah, maybe something like this, right? Yeah, so suppose you had three equations and after row reduce echelon form, you got something like this. Okay, right? You had some three equations A, and after row reducing, you got something. All this will become much clearer when you do that those things. But yeah, so you take this equation. Okay, in this case is 3 by 3. Why not? We can take, right? So you take a 3 by 3 situation. Okay, and you do this row reduced echelon form and you get this. All right. What does this mean? This means that the variable x3 is free. Okay. Now, for this one, can you think of something which has infinitely many solutions? Yes, you can, right? You can just write this. Then this has infinitely many solutions, no problem. Correct? But then you can think of something which has no solutions. This. Okay. And then you don't even have to do row reduce. You can just say, I will start with this one. Why not? That is also an equation, right? That's also a matrix, 3 by 3 matrix. So this is the easy explanation, but using rank nullity also you can explain. We will see that. This is basically the talking about the dimension of the image space. A is a transformation and D2 is in the image. And yeah, but maybe I can talk about it today, but we'll talk about it maybe next. Okay. So this is question number 14. Yeah. So, I mean, we will stop here, but I will assign you some work. Yeah, which will add on top of the last day. I did not send those things actually. Yeah. So I'll just write it now. The ideal thing I completely forgot today when I was studying something which had some idea, ideals, something I can. Then I remembered that I had to give something on ideals. Okay, I had to say something about ideals. Yeah, but it is very very important. So yeah. So what I'm just saying is that just please note this down. Okay. Yeah, I'll just say it very concretely. Otherwise, K is a field, and you look at this ring. Okay? Please note it down. Basic definitions you will find, but this problem you should do. This sequence of problems maybe. Yeah. So I in Kx, okay, be an ideal. Okay. You see the definition, right? Yeah. I in Kx be an ideal. Okay. Uh, yeah. So show there is a unique, and that is the only part you have to show the uniqueness. Show that there is a unique element, or I'll just write polynomial of least. There are polynomials of least degree, right? That you know, but unique polynomial of least degree in I. Okay, and then you like show that f. So say that is g or gx, like show fx in I if and only if fx equals to gx times hx for some hx. Okay, so everything is a multiple. And here you can actually replace this ring by z also, and it would work. Okay, and the challenge is, and this will be interesting. This is problem A. The challenge is to do problem B. Do A for the ring for the ring Z adjoint I. So this will be moved to the new domains, right? This is called Gaussian integers. If you can do this, then it will be nice. We'll see what you need to do this, right? Ah, yeah. Now we can also look at C. Uh, yeah. If two holds show if two holds uh, for Rx, okay, then show R is a field. And if I'm wrong, then give me an example. Yeah, you're putting a question mark. So because I'm running out of time, so I will just put a question mark there. And these are the questions, okay, that if you replace this K by R and if these two things happen, okay, if this happens, then maybe try to show that that R will be a field, okay.
In question number 2, show fx belongs to I, if and only if fx equal to gx.
Yes, gx, yeah, gx.
Gx into hx.
Yeah, this is into, yeah.
Cross.
Correct.
Okay.
So I'll just quickly give you one more question or something similar but different. So M be a module over R, okay, if any if I have to say it in a different way. No, it will become complicated. So just do these questions and maybe just do this. I mean, just yeah, show that 2 is not true for take a field and 2 variables. It's not true for true variables. You can use C also if it is true to prove this, but otherwise you can do this on your own. And this is where real algebra starts. 2 variables. 1 variable, everything is done. Means everything is done in the literature. Maybe you don't know, but you will know soon. Depends on, yeah, just matter of time. Yeah, okay. These are very important. Please do this. And then we will meet on Sunday, right? We'll not meet on Thursday. We'll meet on Sunday, 12:30. And yeah, we'll continue with this only then. Multivariable will do
Yes.
next. Okay.
Yes,
Bye.
sir.
Bye.
Thank you, sir.